supportive.
But do you see? Are there like white schools who do that too?
Yeah.
Harvard
No.
does it.
Yeah.
Really? Okay.
You're cool. That's a good idea.
Right, it's talking about it's a new strain of COVID coming. And I'm like, no, you're all right. It is election year, y'all, so. Wait, I'm like, if I don't win, we're gonna get a tsunami.
Well, it's a consciousness thing. Like you don't really get into that.
If you just like, if you stay clean and be healthy, you be all right.
I mean, if you think about it, like if it comes into, you know what I'm saying. I don't think about that kind of stuff, so I don't get sick. Like,
I don't get sick either. Like
I wasn't thinking about it.
not that saying.
I didn't even know I had it. I'm going to
You
school.
healthy, I just feel like you're good,
I
bro.
feel terrible.
Yeah. Sorry to hear that. I mean, they say it's gonna be similar to the flu and just
Yeah, they did.
be another thing.
I'm on my mom all the time. She's old.
How's your mom? If you don't mind me asking, because I got an older mom.
That's not old.
55. My
That's
mom's
not old.
like 55, I think. Yeah. They like
She
go.
old. She can't be look at that age difference.
I mean, yeah, I feel like I had an old mom too because she had me when she was older, but I grew into it.
I will say I've seen a lot of natural practices to help combat a lot of them, a lot of those things. Like a lot of countries that are in Africa, or a lot of countries that have more natural environments with our food and everything. I've seen that it's not as bad and not as
Because they're not
prevalent.
getting
Plastic. It's so many.
And we not getting, and then they getting the nutrients from all the natural things that they got and their resources.
Mhm.
They gonna be alright.
Yeah, and there's certain like anti-cancerous fruits and vegetables and so many things that are in tropical environments. Things that,
Like they be like soursop is good.
man, soursop is amazing.
Bro, I never
Soursop
had
is
that
amazing.
before. I've been hearing people talk about it.
Soursop is amazing. Guanabana, call in Mexico. It's one of the best superfoods.
Ginger is really good too.
Yeah,
Good
yeah.
ginger root in the
Yeah.
Yeah, I had ginger this morning. And,
That's the immune system. All like this.
so yeah, this.
This.
So yeah, we could keep on talking about that, but man, it's a whole lot that I've learned that has to do with natural living, holistic stuff. But yeah, go ahead and get through here. I was, for the people who came in, we were just going over some of the applications that were brought up in chapter 1.1, where just to kind of help you guys in case you haven't gotten there, some of the support systems that have already been in place and before, or some of the models and whatnot that support, like your biology and whatnot, that physicists have supported helping with creating and showcase in different chemistry, biology, So physics is a good way to bring it all in. So what is the model? That's why we're talking about having models. It is a drawing that we use to form a mental image of the atom that we cannot see directly with our eyes because it is too small. So those are some of the things I was talking about, just things being real small. Aristotle wrote on a broad range of topics, including physics, animals, the soul, politics, poetry. Ibn al-Haytham and Galileo Galilei, so critical to the advancement of scientific practices. So yeah, I just wanted to kind of go through that real quick. Niels Bohr, there's Bohr, equations or Bohr constants, I believe that we use. Yeah, I believe that has to do with light. A lot of times we talk about Bohr for some of the light constants. Scanning and tunneling microscope, scientists can see the individual atoms that compose the sheet of gold. Distance from Earth to the moon may seem immense, but it's just a tiny fraction of the distances from Earth to other celestial bodies. And then this one has to do with the unknown units. It's hard for him to know how big a cable is. So that's why we stress the units. An atomic clock uses the vibrations of cesium atoms to keep time to a precision of better than a microsecond per year. So, light traveling distance of 1 meter. So the speed of light, how fast does it travel a certain distance? Tiny phytoplankton swimming among crystals of ice. I saw that they had another Professor Gordon. From NOAA. NOAA is the National Oceanic and Atmospheric Agency, so that's another.
You want to go to Antarctica, though.
Yeah, that.
I would know. Don't even worry about it.
It is pretty
You don't
strange.
wanna go to
Don't even worry about it.
Why?
Ain't nothing out there. I mean,
The big reason I would consider going there is that the past is. Let me say that what we believe from plate tectonics, they say that a lot of Antarctica was in a warmer climate. So there may be artifacts and things that are in Antarctica that may have been related to pyramids. Galaxies can collide 2.4 billion light years away. Balance beams.
There you go.
Oh, balance.
I'm not talking
Balance
about
beams.
That was terrible.
Mechanical balance been replaced by digital scales. So we have a lot of mechanical balances and digital scales. So we have those here. And then we talked about, this is where we started, the precision, accuracy. I'm not sure why exactly, how many bank stacks make up $1 trillion. Ooh, excuse me. This color enhanced photo shows salmonella, red attacking human cells.
So the red is salmonella.
Yeah, it looks like it. Yep, so that's that. Chapter 1. So now we're going to get into Chapter 2. Before I move on, there are a lot of resources that the book contains. So if you go here to student resources, you'll be able to see certain support resources. So there's the student getting started, student solution guide, reading and note-taking guide, student time management guide, expert TA study, and how to succeed in physics guide. The one that I would like to highlight here, go to resource. One I would like to highlight, how to succeed in physics and reduce your workload. So there are good resources here. Math concepts and principles, physics concepts, energy, momentum, rotation. So it's just talking about the time spent studying and your progression you should aim to study. If you are diligent at the beginning and lay a solid foundation, you will probably actually end up studying like this. Time spent studying should go down as you progress through the quarter, is what they're saying. So anyway.
So the math that's in physics, is it just basic algebra or?
Just shows some of the properties, some of the support ways to, like this is talking about ways to reduce your workload and whatnot. So these are some of those things that I was talking about last class, that we allow for a quicker access point to our solution, rather than having you go through A times B plus C, where you do A, B plus AC, and negative B plus A. Just say that it's negative B times negative A, negative B times negative A, or however that works. It looks kind of strange. Why is it a negative AB plus AC? A plus B plus C, A plus B, and N plus C. So yeah, different ways that you can go faster. Does that make sense?
Yep.
Or does that answer your question? Fractional math. So this is similar to the equation sheet that I have, the formula sheet that I passed around. Just something to give you, just support, review, basically. Substitution method, elimination method, word problems. So this is something real good. I noticed units in physics. See, the very first thing that they talk about is math and then units. So knowing these math, and then that's why we've already gone through the SI units, talking about mass, meters, seconds, joules. And then, much like we were talking about with this formula sheet, shows us the kinetic energy, 1/2 mv squared, shows us different relationships. U, mgh. So if there's ever a time where you forget, then you could come over here and say, man, what is this supposed to be, meter per second squared, or meters per second, or meter squared times second squared? So it'll give you these units. Trigonometry. So that's going to be very supportive here soon with the vectors. Pythagorean theorem, conceptualization, rotation. So this is the sine and cosine. When sine, one of the big things that they don't stress about sine and cosine, like sine starts at 0, but then cosine starts at 1, I believe is how that works. So, and then when we're doing our vibrations or doing our plots and whatnot, a lot of times you'll know whether it's sine or cosine wave by like where it starts. Does that make sense? Have you ever noticed that? Because they'll say like the sine of pi equals 0, but the cosine of pi, I believe, is 1. So
yeah, what are they? It's like what is that? Not range. Whatever you get, like everybody get their own little numbers, or what you call it. Somebody is at 0 pi, and then 2 pi. Somebody else is at
One half of pi.
That would be the unit circle, probably. Maybe the unit circle. The unit circle shows what angles are, like the degrees in.
I'm not talking about it.
Okay. I mean, it sounds like we're talking about the same thing. It's waves. Yeah, see, here's cosine. See, cosine starts at
like
1.
Amplitude and like the period.
Frequency.
Yeah.
Mhm.
But I don't know, you got pictures, but they ain't like the pictures that show the difference. Cause like,
Yeah.
close is one of them is like real, is tighter than the other one for they like wave thing. That's all I'm telling.
I mean, I think it's similar to this, like sine. One of the big things is basically what I was saying, like sine, because this is it right here. Like this is a wave. This creates, the going to pi and then going to 2 pi. Sine going up and going
that's
down.
the period. The period will be pi.
Yeah, right. And then see, cosine starts at 1 and then goes through the origin, going down and then back up. So just a little something, geometry, and the area, volume, demystifying pi, radians, calculus, derivative, integral is an antiderivative, and integral is the area under the curve, all this stuff. So we're about to get into this distance, velocity, and acceleration, displacement. So that's what we're gonna get into today. Vectors and scalars. We're about to get into that. What a vector quantity is versus a scalar quantity. That is gonna be our chapter 2, visualizing vectors. So we're gonna talk about this. Cross products, dot products, science products. One last word. Students new to physics usually want to plug their numbers into the equations as soon as they get them on paper. This is a very bad habit to get into. You should not plug in the values of your variables until you have the solution written as a formula at the end of the problem. There are several reasons. So that's part of the reason why I said go ahead and write what you want it to be on the right side. When we were doing the units, that's a part of that type of flow, is to say, okay, what are we trying to get? What's the objective here? First, it makes your math transparent, which means that if you make a mistake, it is easier to go back and fix, as well as to double check your work. Second, it also makes your math transparent for your grader, so you will get more partial credit this way if you do not get the right answer. That's true. That's very true as well. Third, you may realize that you are missing some important information that is crucial to solving a problem. Going back to that, they're saying that because I would be able to say, oh, okay, you see that it's supposed to be meters per second, but somewhere in here, like, oh, I see exactly where you left out, oh, hour, you didn't cross out hour, you got two-thirds of the way through, but there is just a small part, so I can still give you some credit. But then if you just say, I don't know, or whatever, if you just don't do anything, then, I don't have any way to give you credit. Third, you may realize that you are missing some important information that is crucial to solving a problem. Fourth, it is just a good habit not to rely on your calculator to do everything for you. It may seem a little more difficult to do this at first, but start early and you'll thank yourself later. Yep, so physics concepts, intuition, kinematics. So we're about to get into kinematics now. Kinematics is where the real physics starts. There are 4 quantities that interact in the kinematic equations: time, distance, velocity, and acceleration. Distance, velocity, and acceleration are vectors, whereas time is a scalar. Furthermore, in order for the kinematic equations to hold, the acceleration must be constant. So, I'll come back to this because this kind of explains it a little bit more than where we're about to be. And then trajectory, forces, superposition, and free body diagrams. So that's what I was talking about. Equilibrium, centripetal forces. So, and then it just gets into more and more energy. Energy's many forms. Work energy theorem, momentum, collision. We'll get into collision after that, rotation. So, yeah, everything else is just gonna come later. Alright, conclusion. The goal of this book is to give you a conceptual framework to complement the technical material you will cover in class and in your course book. To accomplish this goal, we have stripped out most of the technical math and tried to get you ready for what you will see by walking through key math concepts in a non-technical way and giving you a conceptual overview of important physics concepts. We hope that the math review is helpful and will supply you with the tools you need to understand the math as it is applied to physics. We further hope that this book has helped you build up an adequate framework for you to hang the technical concepts on when you learn them, and has helped prepare you in a way to make them easier to learn and fully understand when you do come across them in class. As you go through the course, you may find it helpful to review the relevant material covered here before you learn each topic, and as you work your way through how best to understand each concept. Physics is often thought of as a very difficult course, and no matter how you go about learning physics, it will certainly require a lot of work. But if you work to understand the concepts rather than just trying to memorize how to solve specific sets of problems, the class can actually be quite enjoyable. You will get more out of it with less effort, and you will be prepared to solve any problem your professor can throw at you, not just the specific problems you have worked through and studied. We hope this book helps you on your way, and best of luck in the class. So it's a great thing. Of course, if you need any additional help, please visit Very Tutors. Contact us. If you are taking a physics course this semester, you may also be interested in our online physics crash course. For more information on scheduling and pricing, blah, blah, blah. So that is a resource to look into. Wanted to highlight that and some of the information that we are gonna get into. All right, so that's that. So the next point of our topic here, make sure everything. Yep, my camera's still on. This is still going. Cool. So, chapter 2. So we've already talked about chapter 1. We just went over some of the introduction pieces, just talking about some of the history of it. Physical quantities and units, accuracy, precision, sig figs, approximation. We're skipping over approximation. Glossary. So I like how they have, I'm sure y'all have seen the book now, but the section summary is very good, giving you the key points, the conceptual questions, problems and exercises. So and then now y'all see that there's a student guide to this book as well, where it can give you some of the equations and some of the answers to these problems. So yeah, we've already talked a lot about that. All right, section 2. Displacement, vectors, scalars, and coordinate systems, time, velocity, speed, acceleration, motion equations for constant acceleration in one dimension, problem solving basics for one-dimensional kinematics, falling objects, graphical analysis of one-dimensional motion. So, Kinematics is defined as the study of motion without considering its causes. Kinematics is basically the study of motion. That's what it all boils down to. Motion without considering its causes. Just, I know that it's moving. I know the car is moving. I know that the car is accelerating. I know the car is slowing down. But I'm not worried about the pistons and the oil and stuff. It's just studying the motion. So that's the big thing about that. I wanted to watch this real quick. It's not.
The mysteries which lie beyond the clouds have intrigued us since the dawn of mankind. Scientific advances that seemed incomprehensible to our ancestors are becoming our new reality. Innovative companies like SpaceX help make space exploration easier and more affordable. Physics is critical to their continued progress. Pressing beyond Earth's atmosphere, as well as providing a safe return, requires a clear understanding of one-dimensional kinematics, which tracks position, velocity, and acceleration as a function of time. One-dimensional kinematics can describe a particular rocket test like this one. As a rocket takes off, it accelerates upward, increasing both its vertical velocity and position. At the top of its trajectory, it hovers, briefly stationary. The rocket returns to Earth in a controlled and precise manner, landing with as little...
Yeah, so we're about to talk about these plots.
vertical velocity as possible. Every successful test brings us a little closer to understanding the universe and its great mysteries.
Cool. By the end of this section, you'll be able to define position, displacement, distance, and distance traveled, explain the relationship between position and displacement, distinguish between displacement and distance traveled, calculate displacement and distance given initial position, final position, and the path between the two. Cyclists in Vietnam can be described by their position relative to the buildings and a canal. Their motion can be described by their change in position or displacement in the frame of reference. Cool. Position. Anyone want to read? No?
In order to describe the motion of an object, you must first be able to describe its position, where it is at any particular time. More precisely, you need to specify if its position relative to a convenient reference frame. Earth is often used as a reference frame, and we often describe the position of an object as it relates to a stationary object in that reference frame. For example, a rocket launch would be described in terms of the position of the rocket with respect of the Earth as a whole, while a professor's position could be described in terms of where she is in relation to the nearby whiteboard. In other classes, we use reference frames that are not stationary but are in motion relative to the Earth. To describe the position of a person in an airplane, for example, we use the airplane, not the Earth, as the reference frame.
Yeah, so talk about this. We talked about the delta of x is x final minus x initial. And then also how they explain